Okay, hello everybody. Welcome for our weekly lifecycle provisioning and monitoring technical work group in OPI. We didn't have a last week meeting, so hopefully today will be even more productive than usual. On the agenda today, we're quickly going through all just a reminder of all the work streams that we're currently working on, maybe 5-minute updates on the latest developments. And then Andrei from Intel requested an item on agenda to discuss a little bit the topology. So we'll deep dive into that. Makes sense? Anybody wants to add something to the agenda?
And if we have time, Boris, we can probably look at this DMID code validation tool.
Yeah, absolutely.
We run it internally, and of course, it was, I think, just forked from Google. And as soon as you run it, it starts to complain that vendor is not Google and makes it completely incompliant. So, like, we just can discuss how we do, how we approach it and what we do forward. Do we have a list of vendors and so on and so forth?
Yeah, excellent topic. Thanks. Opportunity for all other folks to add more items on the agenda, something that you're interested in, or generic comments that you have on the work stream, on the progress, on the focus, all the different topics that we're discussing, anything that you want to bring. This is a time before we deep dive into actual technical details. Okay, I assume that's enough. So let me quickly share the screen and let's walk through the working streams, and then we can jump into a more technical discussion. As usual, we start with our main repository under OPI GitHub organization, OPI provisioning lifecycle management. Those are the 5 topics that our technical work group is currently covering. Discovery and provisioning using secure zero-touch provisioning, RFC spec, inventory, boot sequencing, lifecycle and updates, monitoring and telemetry. So let's deep dive into each one of them, 1 minute on each, and that will be our 5-minute update. Let me just open all of them. Okay. On secure zero-touch provisioning, SZTP, we have our SZTP repository. There wasn't a lot of progress lately on the SZTP code. I do expect a lot more contribution here. So we did develop the entire Go language implemented SZTP agent running on the DPUs and IPUs that can bootstrap. Andrei, we talked a little bit offline. I'm missing Intel validation from SZTP agent running on IPUs, so it will be nice to kind of show SZTP running on Intel as well. Marvell already tested it. Didn't provide any feedback yet. Chetan, this is action item on you to still provide a feedback how SZTP agent running on the Marvell DPUs. And I did run it myself on NVIDIA. But still, if somebody from NVIDIA wants to rerun it, that will be great. I don't see NVIDIA folks actually joined today. So what's left in the secure zero-touch provisioning? The most important part that is still work in progress is actually the access of the TPM vendor agnostic information, okay? So we did solve the inventory and local access for the serial number and the vendor, which is great. But still the IEEE 802.1 AR secure device identity by accessing the secure storage TPM-like devices in a vendor agnostic way is still unclear to me. So we didn't have much progress, and I do expect something to somebody to maybe help us move this along. So this is the biggest open item in this work stream.
Right. So Boris, to update you on the SZTP execution on Marvell. I mean,
Yes.
it ran without any problem. So
Excellent. Thank you. By the way, if this is a state of action, like how this group thinks that we should document these kind of things, should we have a separate page of compliance, and then each vendor can kind of put a VX or link to the results, or somehow say in a public manner in a GitHub that they tested and this code is compliant, not compliant, anything like that, until we have the CI/CD pipelines to actual hardware that we can automatically update the status. Any thoughts on that? Okay, think about that offline. Okay, so that was on SDTP. Any questions before we move on? No. Inventory, I remind you, we have 3 inventory information. One is local. We adopted SMBIOS, DMI decode. We have examples here how it works, and thank you for Intel to actually submitting pull requests to show how it works on Intel IPUs. Remote network inventory, we focusing on 2 implementations. One is Redfish and one is gRPC. gRPC, we have the protobuf definitions here, and we have the actual repository OPI SMBIOS bridge, which is implemented here. There is one open issue on SMBIOS bridge currently, that CPU information is empty on ARM. And this is due to the Go library that we're actually using. This is by JPipes, hardware library that actually pulls all the SDMI table information. So I linked here the issue on their repository for the ARM and RISC support. And they have a pull request actually to add this support. So hopefully this will progress a little bit. So again, in this space, I kind of expect people to run the DMI decode, SMBIOS, which we did, and show here a few examples locally. But I also want people to try to run the gRPC service that we defined here with OPI SMBIOS bridge. Very easy to run. This is a simple one-liner Docker command that pulls in the Docker image and can actually run the server. And then with a simple gRPC CLI tool, we can send the inquiry, get information. And this is an example how it looks like on Bluefield. And thank you for Marvell team, Chetan, to actually provide us a pull request, how it looks like on Marvell DPUs. So I'm missing the Intel example here, and Andre, if you can take an action item once you figure
Yes, we're working on it. As I said, I think on our Slack, we're just working with lab guys now to have access to external work from our lab. As soon as we have it and we can run all Docker stuff, we'll post it here.
Yeah, well, I'll just create a pull request.
Yeah.
Alok, you have a hand raised. Go ahead and ask.
Yeah. So yeah, this is good. I mean, we are having some progress on the gRPC API, and that as an option for fetching the inventory information from the remote request. For the first option, the one which is Redfish API based, did we had any progress on that one, or because I see no references there, or what are the plans around the first option? How to address that?
Yeah, that's a good question. We didn't have any progress here. Obviously, we have the Redfish spec that is implemented on several DPUs that we have. For example, Intel, as you heard previously, is advocating on a Redfish server running on their IMC processor, and implementing all the standard interfaces. So what are you looking for? Just an example, how it looks like, just a curl Redfish query of different inventory information and see that it matches the local information, something like that, Alok, or something different?
Okay. Yeah. Okay, then we can think of like bringing that as a contribution, or maybe starting with a discussion on that.
Exactly. I was actually thinking about same, Alok, before you asked this question. I was looking at it. Okay, we have proto definitions here for gRPC for Redfish, especially for inventory, which does not require action or post support on Redfish. Again, we can use a standard DMTF Redfish mockup server, but with some sort of scripts or whatever, we can create schemas and pages only relevant for us for this discussion for inventory. So then we can, first of all, we can post examples of the schemas using curl, as you said.
Right.
And then it's let's start with that, and then we can see what we can do next. For example, can we create some sort of script that will convert SM bias output, especially if we're taking SM bias as our standard here, that will convert SM bias information into the schemas for inventory available through Redfish.
Yeah, that's a good idea. Yeah. Anything, Alok, you looking for specifically, like examples, pointers to the mockup server from the MTF? It just
Yeah, I
would
mean,
be
same
trivial.
as what we have implemented, or as for the gRPC, right? The proto definition and the example implementation. If we can have some, like you said, for using the curl and fetching the schema using Redfish API, right? So that way, I mean, I can look into as well on if we can bring that as one of
But
the contribution in that area.
Yeah. What I was thinking, if Redfish API, if Redfish server is running on, for example, Intel IMC, right? There is no reference implementation that we can actually post here, right? The only thing that we can do is just send curl to the Intel IPU and post here how it looks like, the inventory information returned from that Redfish query. That's it. I don't see any example or reference implementation.
Yeah. And is it just the Intel IPUs who has the SNCC BMC, or what about the Bluefield and other vendors?
Bluefield also have the BMC processor, not on all port numbers. As far as they updated us in this work stream, going forward with Bluefield 3 and so on, they will always have the BMC present on the board. So they will support Redfish, because I believe they're using OpenBMC with Redfish implementation. But for example, Vipin here on the call, AMD is not going to have a Redfish server. This is why they're focusing on gRPC implementation only.
I see.
So it's a challenge because we don't see a unification here on the Redfish. Everybody can implement gRPC. This is why I think this is a good direction for this work group. Redfish is not widely implemented on all IPUs and DPUs. So this is why it's a question mark for me. I do understand Redfish is a kind of standard in the server's way, but we
I mean, it's a DMTF standardized implementation. So I mean, we can.
So for servers, it's absolutely a standard.
Yes.
And it's for both BMCs and other server configuration.
But what happens? I understand, but what happens if DPUs and APUs don't have the coprocessor like OpenBMC, like NVIDIA having, like Intel having, for example, AMD Pensando and others? Where are
you have one comment here, right? What if we can run Redfish server on the ARM code? Can that be also a possibility for Pensando, or has that been looked into? Or, I mean, I'm thinking loud here, but has that?
Well, one other thing would be to utilize one of the cores to run something else than regular workloads. Then it could run Redfish server probably.
We discussed it previously, if you remember, on the previous calls. I think Vipin commented that obviously, technically, you can run Redfish on one of the main cores of ARM, right? The question becomes if you start doing provisioning using that. then you cannot really reboot or do any kind of those upgrade operations because you're running your Redfish servers on the same CPU that you're currently provisioning. So that's not going to work very well.
Yeah, I mean the lack of a processor which handles these things offline from the general purpose ARM cores is what I think the main thing is. It's not about running Redfish server versus gRPC server. So
because you're worried about the sort of pre-DPU boot configuration of the DPU.
That, as well as even during operations, if you were to, let's say, reset the card or something, like, you know how you can operate a server from BMC quite well independent of the server itself. That independence cannot be expected in that case. And so if you try to use DMTF standards, the expectation from BMTF is that it's fairly independent of server, but then now we are going to club things and will not be able to support everything anyways.
Well, okay, so if we have, so we know we have DPUs that have BMCs and DPUs that don't.
Right.
We would like to treat those equivalently in terms of lifecycle and provisioning.
Mhm.
We know that from one point of view, a DPU is a microserver. In fact, it is one. It's just some have BMCs and some don't. So what's the decision from this group so far, the thinking on how you treat those equivalently? Or do we have two classes, one using Redfish and one not? That sounds bad to me, but I'm saying what's the current thinking?
The current status of this work group is we identified only two valid paths to go forward, Redfish and gRPC. We tried to develop both of them, and we didn't make a decision which one is the going forward kind of final decision. We tried to develop both of them, show examples and reference implementation, and we didn't have any vote or a narrowing down conversation whether we only use Redfish, only gRPC, or we have no choice and support both of them.
Okay, and when you say
so far, maybe in the future we'll make this determination.
Sure. But and when you say quote gRPC, you know that Redfish can have a gRPC transport, right? So what you really mean is a directly defined set of configuration models for the DPU.
Yes, what we did is we took the DMI SMBIOS DMTF standard spec, and we translated it into protobuf definitions, and we implemented the gRPC service that relates DMI decode, DMI SMBIOS tables directly over protobuf gRPC to the customer in a single query. So the same DMI decode tables SMBIOS information is exactly the same information you get from the gRPC service.
Perfect. Got it. Thank you.
Yeah. So I do look forward for trying to converge between Redfish and gRPC. We just didn't get there yet.
Okay, so converge means
no idea what it means.
So I guess
whether to choose one of them or declare that we have to support both of them.
Okay, I see what you mean by that. Make a decision on it. Perfect.
Yeah, make a decision.
And Vipin, from your view, being a BMC-less DPU vendor, the theory of operation for that in terms of the lifecycle and provisioning is that, I guess, what's the, or maybe you guys covered this and you could give me the 2-line summary just so I'm up to speed.
Yeah, so I mean, the way I'm thinking is that, you know, you use gRPC APIs to update, upgrade, fetch inventory information, but at the same time, since the upgrade is going to be, you know, or for that matter, any operation that you're doing with respect to the platform management will be done through gRPC, and it may require a reboot of a server in order for certain things to take effect.
Ah, right. There's that coupling.
Yes. Because you know, I mean, and that may be true even if you're operating through BMC. It's just that BMC can save that configuration and or possibility of applying it later on, and a lot of operations could be done pretty much inline as well. So that option is not available because you can't alter the system state while it is in operations at that point.
But then it's just a difference in a reboot between BMC and BMC-less configuration, because as you said, Vipin, even if we have a BMC, some configuration or some request will have to reboot the system, no matter what, do you have a BMC or not. And if only reboot is the difference, though, then is it really important? Because I don't that we expect that we will do operations that require reboot on hourly or daily basis.
Maybe it's more than that. For example, your Ethernet controller, if you're controlling it through BMC, then BMC has BMC has a separate Ethernet controller that could be getting IP address from an outside network, for example. That's how several BMCs are. So what could happen is that, let's say you are altering the network interface information through DMTF or through Redfish on the host, that could actually disconnect the BMC itself in case it's not decoupled. So I don't know whether we should allow that in a BMC-less system to go and modify certain peripheral and the information on those things, because we run the risk of completely, detaching from motherhood if we are not careful. Whereas that is not an issue if you have a separate dedicated Ethernet controller and a BMC on the NIC. I'm not saying everyone ought to have it. I'm just saying that, those are the kind of things that you can't assume, which you can fairly easily assume if things are decoupled.
Let's table it for a second. We all recognize the challenge, and we can definitely deep dive on this next time. I want to just finish this page and then switch to our next agenda items. Yeah. So just to quickly remind the action items. First of all, the proto definitions are far from being complete. I just want to show you very quickly. After our last meeting, I actually went ahead and had an action item to implement documentation. So you can see now this is full of blob text documentation from the spec itself. And it's all obviously auto-generated. So you can see all of these fields I explained, and all of these different structures and messages are now have an explanation. But the amount of fields that we have are far from being full. So CPU info, for example, I only put total cores and total threads, and that's it. And DMTF SMBIOS spec has much more information here that we can add. So first action item, I'm really looking for people to come into this inventory protobuf and try to challenge me, add more fields and more messages, fix the documentation, or expand the documentation where it doesn't make sense, right? Let's put an effort here on the inventory protobuf deployer here, and let's make it as good as we can. And mostly I'm asking for help from MD Pensando, since Vipin, you already have gRPC for inventory. I didn't see any pull requests or updates of how this inventory that we defined here aligned with your inventory. So maybe we can extend this using your examples and align it to MD Pensando gRPC APIs. Yeah. Make sense?
Yeah, makes sense.
And the second action item here is related to what Andre was talking about, is the SMBIOS validation tool. Let's open and talk a little bit about that now. So Andre asked a very good question. So my idea was that if we compliant with DMTF SMBIOS spec, that we have to have some kind of validation tool to actually say if this DPU or IPU compliant or not compliant, and what are the exceptions, so that help us, help the customers, and help the actual vendors of the DPUs and IPUs to fix all the exceptions. So while searching the internet, I found the SMBIOS validation tool from Google. So they run this, and this is how the information example looks like, SMBIOS record. they actually parse the information and have the strict rules on all the fields and all the different messages. So I thought this is an excellent example for us to have and to have this tool. So we can just run it inside the DPU, Python SMBIOS validation tool, and it will provide you the different outputs and different errors like this, invalid field, invalid type, invalid record, and stuff like that. So far, make sense? So
Clear as mud, Boris. Keep going.
yeah. So actual Andre question was, when he tries to run it on any GPU today, it provides a lot of exceptions because this is Google implementation, right? So for example, they expect vendor to be Google and stuff like that. So what we said is we're going to start working on this code, and this is open source project, so I expect people to actually contribute this and try to run it, see what exception makes sense, what exception doesn't make sense, and try to fix it and make it so it will run on your DPUs and APUs. And then together we can make it really good product, and we can publish here the results from Intel, Marvell, NVIDIA, AMD Pensando, to actually show who is compliant and what exception they haven't so far. So far, I saw only one pull request from Lee Ballard from Dell, who gave it a first attempt on fixing issue number 1. And this is his pull request. I didn't see any code review or anything like that. So I'm not sure this is the best course of action, but I think there is no other way to actually go moving forward, but for you guys to propose pull requests, propose changes like Lee did here. We can all review it offline, online, whatever you feel like. This is the example when I run it on one of the cards, right? You see immediately the exceptions and stuff like that, BIOS information. And this, for example, one exception that the date is not in the correct format. Format should be month, day, and year, 4 digits. And this is incorrect format from the processor information. So you can see how it should work. So I'm just really, as an action item, looking for your help here. All the DPU vendors, if you can actually run this SMBIOS validation tool and propose pull request, so this validation tool stops being Google specific and starts being OPI specific. So you can either start from Lee pull request, or you can create your own ones, whatever you feel is the best course of action. Andre, am I answering your question?
Yes. So actually, I didn't see that there is a pull request from Lee. I will review it and then we'll try to run it on our board. And actually, you don't even need to run it on board itself. You can just run it with DMI output text to see that it works or not. So, but yes, I think for me, when we run it, the very first thing that I saw that it complains that it's not Google, and then it's complaining handle 2. Also, it complains this crazy complaint about that it should be either main server chassis or rack mount chassis. So, and
yeah, I suggest that
again, I'm still confused with chassis information for IPU. I know that we have a use case when we have a headless IPU config without no chassis whatsoever. I mean, without server whatsoever. So then maybe chassis is applicable, but yeah, like,
let's do
this was strange for me to see.
Andre, let's do 80-20, right? Let's fix or even disable the exception rules. I want to have like maybe 80% of the exception rules working on all the DPUs and APUs, and then we can always add more exception as we go, right? So at least I want to have a baseline that actually passes on all the relevant information that we have. Maybe we can have the protobuf as a kind of first draft of all the mandatory information that we have that we actually verify, or any other proposal. But if things doesn't make sense, like it's Google, just disable this rule and just move forward. Let's have a pull request when we have most of the things already figured out. One of the things we do see today, for example, is incorrect date field, which is a very valid exception that we don't want to skip actually, but we want to raise and fix as soon as possible. Make sense?
Mhm. Yeah.
Otherwise, we'll just
I'll
end
have a
up
look
with-
at this. I'll have a look at this pull request and see. Yeah. Okay.
Okay. Everybody else makes sense? Chetan from Marvell side, I know you're already looking into that validation tool and playing with it a little bit, right? Should we
Yeah.
expect some pull requests from your team?
Yeah, sure.
Okay. Excellent. So I'm looking forward to have that pull request. The last remote inventory here, I really need help because I'm not savvy in these protocols. This looks, if the previous one was from network perspective, from network we can send Redfish or gRPC, but what is happening from the host operating system or the platform BMC? Okay, perspective. We have a lot of standards. We have NCSI with DLOM commands or without DLOM commands. We have PLDM, we have VPD information. This is one example from VPD information that I can fetch from the host OS. Just an example. Obviously, we're looking to have exactly the same information presented from all the three inventory methods. So I'm really looking for some help. Can we actually standardize how DPUs and APUs presented to the, let's say, platform BMC? For Dell, this is a real pain point that we're looking to solve. So if we can try to standardize how all DPU and APUs present themselves to the platform BMC, let's say iDRAC and Dell use case, I think it will be a huge win for this work group in this remote host BMC inventory workstream. Anybody who is familiar with that protocols or think that they know solution and know how to move forward, I'm really looking for your help. Questions, comments? Okay. Since we used a lot of time, we'll skip today the pre-read on the boot sequencing. Nothing changed here. You can read all the different details on this page. The only comment that I have is we have a pull request from Ted to expand the boot sequencing, and I see absolutely no code review. So I want to use this time again to remind you to look in this pull request in the boot sequencing page. There is a lot of changes here. If you want to look at it split ways, you're welcome to do so. But basically, try to do the code review and see if this is something that is helpful. Ted was giving it a shot of actually solving and expanding my question into actual answers. How can we standardize the boot sequencing operation between the DPU and the host? So very welcome the contribution. I'm not reviewing it by choice because I'm doing all the reviews so far. So I want other folks to give a chance to review it before I give my comments. And I will promise to review it, the last one. And we're also skipping the lifecycle management. This is the new addition to our work stream. It have zero information. Basically, that we want to way to reboot a device to update the firmware, the OS, software application, update, recover device, factory reset, and a way to debug device. Intel is obviously pushing for the Redfish for all of those operations, which is a very understandable way. And we need to declare if this is a correct way or no. And this brings us back to MD Pensando not having the Redfish server, so we can circle back later on this. So let me yield the floor to Andre, if you can bring those diagrams that we wanted to discuss, and we can.
Yeah, actually, it's Maciej, because we had the discussion with Maciej and he prepared some diagrams. But I think our main question was, and we started it 2 weeks ago when Maciej had this question, if we go to diagrams we have on provisioning, there are what 3 pictures we have there for different combinations of hardware components. And so our question is, first of all, how complete those combinations are. For example, on all those pictures we have 1 gig is used for out-of-band management, but we believe that there is a complete and like completely legal use case for Ethernet, high-speed Ethernet devices to be used for in-band management. So that's one topic we want to discuss. And then actually it's linked to discussion we had earlier on this call about this BMC, not BMC, BMC running on cores. I think we're still in a quite gray area. What's the difference between BMC and BMC-less configuration? So we also have some options we want to discuss to see how we can progress here.
So first comment that I have is to a question how complete this picture is. Obviously, it's not a complete. This was iterative work that we started to do. We didn't have any diagrams at all. So I created personally all those diagrams to have something to start the conversation is. And I was trying to put on all those diagrams as much information as I could find. So all the different blocks that you can see on those diagrams are, this one is this is your intake, but I'm talking about the original diagrams, right? So all of those diagrams are just having a lot of those different components that I thought could be relevant. And the idea is obviously like you did is take these diagrams and extend or change them as much as people think needed. So definitely it's not supposed to be a complete picture yet. Hopefully when you take it, shot at it, Marvell takes a shot at it, NVIDIA already did one shot on it. So obviously once we have one round of all DPU vendors, we'll have a more complete solution here. Make sense, Andrei?
Yeah, so how we progress here? For example, again, go
Pull
back
request.
to this for out-of-band management.
Propose pull request.
Okay, so then
as easy as possible, and then everybody can review the pull request and either agree or disagree and give you comments inside the pull request, so it's all documented on GitHub. Obviously, in-band management is something that is have a real use cases. Some customers are not willing to connect 1 gig out of band management at all, so that's a valid use case for sure. You can either make it like instead of why not, you can make a note that it's optional, or 1 gig is optional, or something like that. But yeah, but yes, that's a good direction for sure.
okay, so I think it's clear about in-band management. So we will submit a pull request to add in-band management here. So then I think, Maciej, we can go to this, yeah, exactly, to this picture, and you can explain what was our thinking behind it.
Well, technically what we are, seeing, well, my main thing with OPI, maybe what I'm seeing in the diagrams at least, is that we're trying to satisfy absolutely all of the different deployments. That's fine. It's just I'm trying to figure out what would be the most accurate way of encompassing everything. Actually, there are certain, let's say, the companies or the products that their companies create. For example, Marvell, where the BMC does not exist, right? As the XPU BMC. So I have one of these covered here. One of the approaches with the virtual BMC would be here. This is kind of Intel thing, where we have the IMC here, and there is the completely separate chip approach. I'm kind of wondering whether all of the approaches have to be, whether we are taking all of them into consideration. Are we going to mandate something within that? For example, the BMC is absolutely necessary for the XPU to be within a platform. For example, if I'm thinking a case where the BMC is not managing the IPU or the XPU at all, meaning it's a completely separate thing. Still, it's within the host, but aside from the DPU being or the IPU XPU being a PCI card, It's just thermals and power. It's not necessary for the BMC, for the host BMC to manage the IPU at all. So I'm just, it's a general take on, you know, all the various things or the various deployments that we have, and maybe it would be even prudent to outline those, that we are taking all of these into consideration. Maybe there is going to be another one that we don't even think of, but I think at least that could be a baseline for, you know, management and lifecycle, to be honest, because that's effectively at least management of the IPU. That's the main, let's say, opener for the open number 2. I have it's directly connected to the open number 3. Do we standardize at the OPI level the role of the XPU within a system or the platform? For example, is it a peripheral towards the host? Is it a separate platform with the host and standalone? I know that the standalone case was outlined in the in one of the diagrams here. Do we mandate anything like that? Because, for example, aside from me saying that the XPU is a PCI then card, the rest of XPU management may rely on the XPU's role, to be honest. Because, for example, if it's a peripheral towards the host, it's technically relevant that the BMC is managing that, aside from just power and thermal. But if we're turning the things around, if the IPU if the XPU is more important than the platform, to be honest, and it might be a case, effectively, if you're trying to isolate the host and the IPU, for example, in a bare metal scenario, you might want to have the XPU and the host being managed completely separately by 2 different entities. In a
one comment, Matej. We had this conversation like when we just formed this work group, right? And
I joined late. Maybe I'm.
Yeah, no worries. So I'm
Mm-hmm.
just updating. Yeah. So we had this conversation, and we actually said that we don't see a way that we can standardize on this. We will leave it to DPU vendors and the customers, whatever option they want to deploy it, whether they want to deploy DPUs as peripheral, as an add-on card, accelerator card, that's fine. If they want to deploy it as a separate platform that controls the host and being completely independent, like Intel is showing the IPUs being a system that is controlling the host and being managed separately, that's also fine. If they want to be completely independent, like JBOF use case, when DPU is the root complex of the drives exposed to the network, that's their choice. That's fine. We don't want to mandate it. We don't want to limit, and there is no point in discussing that. That's fine. We just recognize that all those use cases are a possibility. If we find something that actually requires us to force any of those decisions, we can revisit that. But so far, we didn't find any, right? We're focusing on bootstrapping the first day 0 provisioning, and we all voted on secure zero touch provisioning for 0 touch, right? So the DPU is supposed to bootstrap itself using the SZTP protocol with a bootstrap server. We're talking about inventory information, whether it's Redfish or gRPC, local using VPD and CSI or PLDM, or the local from inside the DPU using DMI tables and stuff like that. We just started the lifecycle with reboots, factory reset, software, firmware, and OS bootloaders upgrades. I don't know yet how to do it. So again, those diagrams are just showing different deployment options and different variety of the different cards. So we didn't actually feel a need to standardize so far. So maybe it makes sense, right? No,
I mean, yeah,
no?
sure.
Yeah,
It helps a bit, though. Sometimes it feels like if there is too much options, everyone will just implement everything, and then, you know, doing a cross I would say, I wouldn't say standardization, but qualification, it's going to be it's probably going to prove to be a mess. But this is probably the reality. But
yeah, but that's different, right? The deployment, different deployment options, and actually standardizing on the ways to use and protocols and stuff like that, that's not mutually exclusive, right?
Mhm.
So, for example, I don't care if DPU is a slave peripheral or the separate master, separate platform, or actually, you know, the standalone, like gateway or JBoF. The inventory, for example, information is always through the gRPC, for example, right? So that's a standard. You don't need to implement it 3 different ways. You see what I'm saying? It's
Yep,
mutually
but
exclusive, the different-
I would probably have more a discussion of, you know, the position of the host BMC seen by let's say how the iDRAC positions itself within the XPU, but maybe let's go here with my let's say more defined thing. So I'm still trying to figure out the Redfish proxy within the NIC BMC because it doesn't make much sense to me, to be honest.
Okay.
If the Redfish server and all the other KVM things exist on the platform BMC, what's the point of actually having the Redfish proxy at the Redfish level on a single because it would make sense in one situation where I have management or some kind of network communicating directly only with Redfish server on the NIC BMC without any connectivity towards the Redfish server here,
So
meaning no external connectivity.
Yeah. So as I said previously, this edition of the Redfish proxy was added by NVIDIA. And in order to explain that, they added this text box beneath it. So we can actually try to understand together what it means. So what they're saying is the user can obviously interact with NIC BMC directly with a management port shown in blue, right? So you can go through 1 gig management Ethernet directly to the Redfish server of the NIC BMC, and that's pretty clear, right? The other way that NVIDIA proposed to use Redfish is or by enabling a local Redfish proxy on the NIC BMC, shown in orange, whose role is to request commands from the platform BMC.
But then there is, but then technically.
So it seems to me that the Redfish proxy here is a client.
Yeah, but the Redfish technically would have to have some kind of hierarchy, I think, in this case, who is more important and who is being interfaced. Because if Redfish servers are interfaced separately, and then there is some kind of Redfish proxy, it doesn't make any sense. If the platform BMC is the king in this configuration, meaning, for example, if I interface the platform BMC and I'm expecting the platform BMC to have a subset, meaning, for example, the NIC BMC is a peripheral, right? So then I'm expecting that a sub tree, like a computer system for the DPU, or network interfaces or something, or even a separate chassis.
No, I think
under that tree.
Let me try to explain. I think I understand what they meant here. There is, let's say your IPU is a master in this environment, right? It controls everything, right? And then the customer wants to manage the system, so it goes only to the NIC BMC. That's it. It doesn't work with platform BMC at all. It only works with NIC BMC. But there is information that the DPU cannot access without having an access to a platform BMC. For example, power and thermal and stuff like that are not available to the DPUs. DPUs are not connected to those I2C buses and all the different peripherals that a platform BMC has access to. So the idea here is the NIC BMC will go ahead and query the platform BMC for all the missing information that is not available directly to the DPU. So the customer then can access only a single point, which is a NIC BMC, and get the complete picture of everything, right, from the NIC BMC. So the Redfish proxy here is just to fetch the missing information that NIC BMC has no access to from the platform BMC and put it in the NIC BMC Redfish server so the customer can have a single point access.
But it's only related just to the IPU, or is it more extending to the whole host?
You decide. I don't know. For
Because,
example,
okay, it might make some sense if
let's say thermal. let's say thermal. Maybe NIC BMC have no idea what thermals are, or I don't know about the slot that the NIC BMC is inserted in. It has no idea, but the platform, the BMC has this information. So I think the idea was to take the missing information from the platform BMC and complete the picture. This is why the Redfish proxy here was proposed as an option.
Okay, the one with, you know, opening the scenario where there is a separate chip that doesn't have access direct interface towards thermals.
You never
the
have
IP.
this direct access, right?
Well, it
DPU cannot access the server motherboard information, either I2C buses and stuff like that. Anyways, server.
Well,
will not allow this.
you definitely have your own thermals in the DPU unless there
True.
there are no peripherals. You have to report something. So in this
That's-
case, if we, you know, with
that's
the
absolutely
IMC,
true. Yeah.
with the IMC,
That's
it's not
true.
a problem to report that. So,
Yeah, the information, the sensors that you put on the DPU, obviously you have access to. That's true.
yeah, it would be interesting to see what kind of missing information they are trying to do it, because to be honest, it makes some sense for, I don't know, power. If I have to do power cycle of the card, maybe. But if I have to request the reset of absolutely everything, I would probably go through a different communication directly to the BMC.
But
okay.
maybe, but then you as a customer will need to manage two management endpoints. Sometimes you will go for the platform BMC, sometimes you go for the NIC BMC.
That goes. Is IPU a separate platform or is it peripheral? This is effectively
and I
baseline.
think that this use case was trying to present what happens if NIC, if BMC, if DPU is a master in the system, is a single point, is the manager of the server itself. So the customer will probably would like to go to the DPU only to manage the entire system. And I think that it's not very interesting what exactly information the Redfish proxy provides. I think the idea here is pretty clear that possibly there is a missing information that we need access to, and what is exactly that missing information is up to you. You decide.
No, it's well. If platform, well, to be honest, those are two different vendors. They would have to establish some kind of API. So I'm not affected. Well, okay. If OPI,
yes.
well, sure. But those just before and during this meeting, Boris, you've mentioned that we would like to have some kind of standardization around what kind of schemas, for example. What is the representation of that? So here there is definitely some kind of
but let's say the missing,
OPI.
Let's say the misinformation is the slot number or something related to the slot that DPU, the PCI Express slot that DPU is in, right? So that is a simple Redfish standard command of getting the slot information from the PCI Express tree of the Redfish schema. Just an example.
Yeah, I think we have three. Actually, we were talking about that whoever's using the schema, they want to use only out-of-band management connecting to NIC BMC. So NIC BMC collects all this data from Redfish, but we can completely reverse it and say that if management is connected to platform BMC, then this proxy will get some information from Redfish server on the NIC.
That's a valid use case. You can put
it back. Or if we want to break this connection between these Redfish servers and have only like two separate management, it's still possible. Actually, it's possible for in-band management as well, or out-of-band management connected to NIC, because we have this NCSI connection going to platform BMC. So eventually, actually, we can have a pass-through mode. So even if I connected to my NIC BMC or IPU, DPU, in pass-through mode, I can have connection to Redfish running on platform.
which is not represented here, Andre, right?
Exactly.
So
this is not represented here, so that's a.
But NCSI is represented here. You can see that there is a RBT to NCSI.
Yeah, but it's connected to IPU, DPU, but not connected to NIC BMC, which is a bit confusing. But
exactly, and because Intel joined just recently, and you have all this knowledge, so I expect you to fix this and show the missing connectivity here. For example, RBT, is it connected to the ARM cores of the IPU or to the NIC to the IMC, for example, of the GPU. In your case, SDTP agent, SDTP client is not running on the main ARM cores, but instead inside the IMC. So I do expect for Intel to take this diagram and change it a little bit to more reflect how your DPUs and APUs look like, right? Maybe you have more information. This Redfish proxy, what physical connection is it using? Is it RBT, I2C? What actually are we doing here? So I do feel that this diagram needs to be heavily edited to represent the actual.
Yeah, there are so many permutations here, Boris. We can even talk about that if I have IMC in case of Intel IPU, and I have this 1 gig management port connected to NIC BMC, I can connect it to host 1 gig Ethernet on platform BMC, and then I can control my system completely through band interface through high-speed Ethernet.
Let's create the diagram and create a pull request and commit it. Absolutely.
Yeah, okay.
Because
Sure.
you see here that a lot of blocks here that you showed on previous is actually not applicable to Intel. So I do want this to be fixed and changed and show another diagram which is accurately representing stuff. And I'm taking Intel as an example. All the other vendors, please do the same, right? If you see inaccurate description of your cards and all the different interfaces that are presented here, please do go ahead and fix those. And together we will make this a real work. Otherwise, I have no knowledge or very limited amount of knowledge on all those interfaces, only the cards that I actually opened the block diagrams and the data sheets and looked into. So help me out here.
Alok also has inserted a comment during that, probably for during the part where I was trying to ask whether we are standardizing the role of the XPU or the hierarchy of the entities, for example, because yeah, definitely the hierarchy of entities is going to directly mandate the boot flows. Seriously, it's not going, unless we're going to have different sets of flows.
But you understand, you understand that the rack, I don't know, let's say 50% of the customers still seeing DPUs and APUs and accelerator card peripheral to the host. We cannot change that. And maybe 25% of the customers seeing DPUs and APUs and really a master of the system and managing more than one server even.
So yeah, probably so we would probably end up with just saying that it's going to be an accelerator card or a boot or a bare metal hosting card, like managing the host the other way around, and they're going to be two different flows, and we're going to be end up with that, and that's fine.
Yeah. And also the different deployment methods are not changing the physical protocols, connectivity, right? NC
physical protocols, no. But for example, if there are different flows and in some BMC is involved, being the host BMC, and in some not, it's going to be at least a direct impact on the implementation of what iDRAC is doing, depending on the adapters that you're interfacing, right?
Oh, correct. But let's do like this. Let's do, first of all, a block diagram. Block diagram that will accurately represent the reality, what different physical interfaces and implementation are there exist. Then we can add several workflows, whether it's peripheral, whether it's master, whether it's completely standalone, and then show those connections on the same block diagram, okay, and different flows. Maybe this will help us a little bit move forward, right? The physical is not changing, the workflows are changing, and we can show different examples. And then if we see similarity between different vendors and the actual need for standardization, then we can vote on something. But it's very hard to do so until we actually see the complete picture. And this is what my attempt was, to show the complete picture on the same diagram with all the flows at the same time. Not all of them are active every time, but I tried at least to do all the different flows on the same diagram. But we can actually create a different, we can have a block versus then separate different flows and separate it like that, if it makes sense.
So from my understanding, this doesn't seem to be like a provisioning kind of subject. This is kind of a deployment model kind of subject.
Yeah,
We could try
absolutely.
to even we could even try to incorporate, for example, that there are these kinds of models of the adapters that we're taking into consideration. This is the question that there might be a different peripheral. It might be a peripheral or a separate platform. Then we have the pictures for a standalone, right? This is kind of a top level view of what we're trying to achieve, and then up from that, several things are inherent.
But if you, but if you don't have a model for how the thing interacts with its hosting system, or even the rest of the solution, if there isn't a set of models, then how would you know the proper approach to lifecycle and provisioning?
No, I'm not saying that I'm going to dismiss that.
Okay.
I'm just stating that this represents, actually, at least to me, maybe aside from these particular elements, it's just I'm taking a Marvel card or an IPU and I'm just putting another platform. There are physical interfaces, etc., but the way they work, the way for example, whether the host CPU should be able to manage the IPU, which is a perfectly viable case for an FNIC, right? For a foundational NIC, like, I don't know, X710 from Intel, right? It's just you're taking something like that, and you have different flows. I mean, at least those were well understood because of the market.
I think Alok in the comments have really good points, right? Just pay attention that look at the comments in the chat. I created these diagrams to be block diagrams without actually showing the flows themselves. So if we're talking about flows, I really agree with Alok that the boot sequencing, the provisioning that we currently trying to expand will dictate the different flows. So maybe we can leave these diagrams as block of what is possible and available without interpreting is what actual the data flows and what is actually being deployed and connected. And then in those work groups of how we do the management, the life cycle, the initial provisioning and stuff like that, we can actually pinpoint to actual flows and create a new diagrams with flow diagrams and not block diagrams as here. Here, I wanted just to capture the different physical interfaces and connectivity that is possible in DPUs and APUs workflow.
Naturally, it's just if you remove those, it's still valid. Meaning, if I remove Redfish clients, for example, Redfish servers from this picture, this is management. This is kind of I would draw a hierarchy, but it's kind of based like this, right? If I have an external client, am I going through BMC? No matter what kind of interface, to be honest, I have different Ethernets here or there. I can do NCSI pass-through. I can do through high-speed Ethernet. I can do it
Not
here.
on all DPUs and APUs. This is why this diagram were really helpful, because sometimes you don't have RBT. Sometimes you don't have I2C connections, for example, for pool inventory or PLDM or any other information. Sometimes you don't have serial connected. So I needed these diagrams because I never saw a diagram of actual host BMC, platform BMC, DPU, and DPU BMC on the same slide. This is why I created this. And then I just wanted, without any different flows, I wanted to put a different components that make sense for lifecycle and provisioning. For example, Redfish client or SZTP agent or auto collector, right? Nobody can disagree that auto collector is running on the main ARM cores of DPUs and APUs, for example. Correct, Alok. So yeah, SZTP is not talking about Redfish, and we voted that SZTP is a standard in OPI to deploy in with zero-touch secure provisioning for the DPUs and APUs. If somebody wants to use Redfish to provision DPUs and APUs, that's totally fine. We just don't mandate it, right? At least for initial bootstrapping, because we didn't want to have two standards for that. So if Intel wants to do day zero provisioning and be compliant with OPI, they have to do SZTP. If they want to do some additional method, for example, with Redfish, for sure, why not? But the official OPI method is absolutely SZTP.
But are we planning to capture all those different implementations as the reference architecture implementation, or excuse me, or how? I mean, I see interesting discussions today in this call, and what Intel is advocating. I see what they are coming from, and so I mean, these are valid questions, and yeah.
Good question, Alok. I saw from Intel that SZTP is acceptable by Intel, and this is a good direction. And moving forward for day zero bootstrapping, SZTP is the way to go. I think that the Redfish discussion is day one. The actual upgrades, reboot, factory reset, inventory information after the initial bootstrapping happened. Correct me, Intel folks, if I'm wrong.
But that depends. No, I mean, we can use Redfish interface and APIs for like initial provisioning, for example, in case of.
You can.
I haven't gone through the in detail spec of secure ZTP, but maybe for example, the attestation when we are building the initial trust establishment and those type of the flows which can go as part of the initial provisioning.
Absolutely. You can use Redfish. You can use proprietary gRPC like AMD Pensando does, but it's out of scope of OPI. OPI decided that we're going to take one standard, which is the best in the industry for secure and zero-touch provisioning, which is SZTP. And all the rest vendors want to do proprietary. That's fine by them, but this is not standard in OPI, and this is not forced on all the vendors to be compliant with or whatever. If somebody wants to implement PLDM and we don't think PLDM is a standard, I don't care what vendors implement it in addition to SZTP, but they have to implement SZTP. Make sense? For day zero, right? Bootstrapping. You coming from the factory, you either have no image or you have very old image. You now just want to bring up to speed, gain trust with the network, mutual trust, right? DPU trust network, network trust DPU. You want to have all the OS and firmware, all the bootstrapping scripts get to you in a secure security assigned manner. Upgrade your DPU independently, automatically. Then you have your Redfish server, you have all the other agents and OS and up and running that can immediately send you the inventory information and all the rest of the stuff. And then day one, if you want now to upgrade anything, you can go whatever direction we haven't chose yet because we just started the lifecycle workstream. Whether it's Redfish or gRPC or something else, I don't know yet. We haven't developed it yet. But for day zero, I think we voted. Unless anybody is challenging that vote again, we can obviously open it and discuss again. But I think so far, there is only one way which is OPI compliant, which is SZTP. For all types of deployments. You can be standalone, you can be inside the server, you can do whatever you want. For example, NVIDIA has RSHIM interface that they implemented over USB and PCI Express that you can push the image over the RSHIM interface. It's not relevant for OPI because nobody else can implement it. And we cannot force Intel, AMD, and Marvell to implement RSHIM interface over USB and PCI Express to push the images. So it's irrelevant. NVIDIA will keep that interface and we don't care about it because it's not a standard anywhere. Make sense? Alok?
Yeah, I think that all makes sense. And then we have to have some, like you said, discussions like, I don't know, on the call flows and the workflows that we are discussing today. Will that be captured somewhere as, for example, the reference?
Yeah, we captured here
or...
on the lifecycle. I put in the chat on the lifecycle MD page. We captured that we want a way to reboot the device, firmware update, OS upgrade, bootloader, software update. We want to recover device, factory reset, and the way to debug device. How we do it? I'm really looking for volunteers to start and develop this workstream. If we think Redfish is the way to go, how we accommodate BMC-less environment, for sure. Let's have this discussion. And then we can have this diagram that Intel is sharing right now that I created as a block diagram, and then start adding different arrows and different relevant workflows on this diagram, because this is just a hardware or service-oriented diagram, which is not supposed to represent different workflows. Make sense?
Yeah.
Andre, make sense for you guys?
Yes,
Yeah.
as I said last time, we're looking at ZCP. We're not discarding it. So, but in parallel, as you know, we're looking at Redfish as well through Redfish. So,
That's totally valid, right? We cannot dictate you what you implement in addition to SZTP. That's fine.
Mm.
As long as
Also
SZTP
just-
can run inside the IPU, that's my concern.
Yeah, and also just to add on that, I think if I listened it correctly, the discussions and the presentation that we just had, I mean, Intel is pushing the in-band management as well, and I think that is also an interesting use case to see, especially around the edge deployments, right? When we have the form factor considerations and those type of deployment scenarios, I think that would also be good to discuss in detail and see how the call flow will look like in the in-band
Absolutely.
management case. Yeah.
That's a valid point. We never dismissed the in-band management. We always said that either out-of-band or in-band management are both valid use cases for deployment.
Yep.
And secure zero-touch provisioning, for example, can run either out-of-band or in-band. That's fine in both use cases. So yeah, it's just not maybe showing on this diagram, but it was implied that you can come into management system from either out-of-band or in-band.
Okay, sounds good.
Okay, we're way over time today, so sorry for those who had to drop. I'll post
but it was good discussion.
very good discussion. So
Yeah.
we have a lot of action items, and I do feel that from week to week we are not getting to address any of those. So I really need your help, folks, on this call to actually take seriously the action items, try to come up with any solutions or proposals. Otherwise, we're just talking, and talking is fun with smart guys, but we have work to do. So hope we'll see more contribution going forward.
Being on a couple of standardization bodies, it's not bad.
Thanks. Okay, cheers. See you next week.
Thank you. Bye.
Thanks, bye.